National 5, welcome to another installment of Mr. Bull's Physics. To the wider physics family, this is a solar system that my National 5 class made. Now, it's a very special solar system, and I'm just going to talk you through it. Clearly we start with the Sun and the terrestrial planets, and we've got some nice little rocket ships. We start off with Mercury, and a satellite that is probably triple the size of Mercury. We then have Venus. We have more technical satellites that are not in proportion, but still excellent nonetheless. We have the Earth, and we have Mr. Bull, spelled B-O-O-L, on any part of the planet. Pick it up and put it on any part of the planet. You'll only be able to put it on South America and Africa and the Middle East, but that's where you can put Mr. Bull. So if you come into the classroom, place Mr. Bull somewhere. Then you have the Mr. Bull planet. Now this is a special feature with two Mr. Bull moons. So it's got two natural satellites orbiting. Looks like Mr. Bull is not going to survive anytime soon because that asteroid is coming straight for his face. So thank you National 5 class for doing that. We have Mars with its top hat and the Ross and Nancy if anyone watches The Expanse on Amazon Prime, new season coming out, season 5 on 18th of December. And then we have another rocket ship with my face right in the middle. And then we move over and we come over to the gas giants. But before we come over to the gas giants, we see the asteroid belt of Mr. Bull. So my National 5 class has taken this solar system to the next level. And instead of the asteroid belt, it is now a Mr. Bull belt. But we move on from that and we look at Jupiter. And with some great proportion sizes here. Another rocket ship with my face on it. And Saturn, Neptune and Uranus. So, the solar system as thought of by National 5. Let's get on to talking a bit about electricity. Come on, the vaccine is so close and we can move on with all of our lives. It is going to be a memorable occasion, physics family, and we're not there yet. We have to keep persevering, but we are so very close. But for now, we're going to keep on the videos. We're going to keep doing the fun. We're going to keep learning about electricity. And physics family, I'm going to ask you to keep on subscribing because we have not moved. This is the first we slip up this week of not having any subs. Not having any subs. In fact, we dropped and then we went back up to 222. And we're trying to get to 300 by the February weekend. So you know the things that are at stake with this. Or you know this in the physics family. So I'm going to ask you, share it with your friends. Share the channel with your friends. Let's see how many subscribers we can get. Okay? But for now, we're going to now talk about physics family. Come on. You know that physics family. Hashtag physics family. Put it in the comments below. Put it in your Instagram. Put it in your Snapchat. Physics is family. Now, shout out. Why not actually shout out some S2s today? S2s that saw me cycling home and they were shouting Mr. Bull, cheering me on. You guys know who you are and I appreciate you, and I say this shout out is for you guys. Alright, this shout out is for you. You know who you are. Now, we're going to be talking about potential dividers today, or sometimes known as voltage dividers. So let's get cracking into this. Slightly tricky, but we'll do through some examples and we'll be absolutely fine. Now, just a reminder on a couple of things. We need to know the series circuit laws for voltage, particularly voltage. We know in a series circuit that voltage should all add up, every component should add up to the supply voltage. Okay? So we should know that. Potential dividers are just series circuits. Very straightforward, very easy. We also need to know variable resistors. Now variable resistors are resistors that change resistance, okay? So they're not fixed resistors, they can change, they can vary their resistance, okay? Now that's going to be extremely important when we talk about something after potential dividers called switching circuits, okay? But for now, potential dividers. So, what is a potential divider? A potential divider consists of a number of resistors in series connected across a supply, okay? Now, let's see what that looks like. So this would be a potential divider. Potential divider are often seen as being resistors that look like they're vertical. Alright? So look like vertical. Sometimes you don't get a supply voltage, sometimes you get what we call a voltage rail, which will be some of our examples. But it has two resistors in series. Now there's two equations that I'm going to show you and we're going to use in the examples of today's lesson. One of them is V1 over V2 equals R1 over R2. And another one is V2 or V1 equals R2 or R1 over R1 plus R2 times the supply voltage. Okay? Now, what are these? They are simply just ratios put into an equation so we can understand it. This is in every National 5 equation sheet. Okay? Now, the best thing to do here is to just do some questions. Okay? But remember, the larger the resistor, the larger the share of voltage it will have. Okay? Just always remember that in a series circuit. So, let's just crack in with some examples. So calculate the voltage shown on V2. Okay? Now, little hint. There's two equations. We're going to use one of the equations because we have the supply voltage. Okay? If you don't have the supply voltage, you would use V1 over V2 equals R1 over R2. But if you do have the supply voltage, you're going to use this one here. Okay? So, let me show you. You're going to use this one here. And we're looking for V2. So V2 equals R2, because it's the resistor 2 of the voltage 2, over R1 plus R2, all times the supply voltage. Okay? Now what does that mean? Well, 600 over 1000 plus 600 times 6. Okay? So 600 divided by 1600 times by 6 gets us, I've got the answer here, 2.25 volts. Okay? 2.25 volts. So we only use that equation when we have a supply voltage given to us. Now the next one says state the voltage of V1. So if we know that V2 is 2.25, we know that we need to add something up to get 6. Okay? So 2 is 2.25 plus whatever to get 6. That should be 3.75 volts. Okay? Because 3.75 volts plus 2.25 gives you 6 volts. Now, 1000 ohms needs the greater voltage, share the voltage, which it does do, because that's bigger than that one there. Alright? So, that makes sense. So when we have supply voltage, we use this equation here. Now, if I wanted to find V1, I could easily put V1 and just made the resistor 1 up there. So I'd be using 1000 instead of 600, if that makes sense. Right, let's try this one. Calculate the voltage shown on V1, but we do not have a supply voltage this time. So what we're going to do is we're going to do V1 over V2 equals R1 over R2. Okay? So V1 is 3000 divided by 1000. Excuse me, that's the resistance. So 3000 over 1000, if that was the resistance, and then it should be RV1 over 4. Sorry, I've just flipped them around by mistake, okay? But you can see that that is the resistance. Now, V1, well, 3000 divided by 1000 should be 3. Cancel out the 1000. So 3, bring the 4 up, 3 times 4 is 12 volts. Does that make sense? Yes, because 12 volts takes up the share of the 3000 ohm resistor, which is bigger than the 1000 ohm resistor. Right, then it says state the supply voltage. Well, if you know that that's 12 and that's 4, then that must be 16. Okay? Because everything must add up to the supply voltage in a series circuit. Okay? So we didn't have the supply voltage, so we use this one here. Next one. Now this is a potential divider circuit, absolutely fine, but it's now on its side rather than on vertically. Okay? Now, there's two ways to do this. So let's split the board in half. Let's do 1 and let's do 2. Okay, there's two ways. One way is just doing exactly what we said. We've got the supply voltage, so we can just say V1 equals R1 over R1 plus R2 all times the supply voltage. Okay, so R1 is 30 over 30 plus 20, which is 50, times the supply voltage, which is 10. Okay, now that should give us 3/5 of 10 is 6 volts. Okay, which is the correct answer. There's another way to do it though, and it's using V equals IR. So for this one, you would actually start by finding out the current, okay, because the current's the same in a series circuit. So 10 divided by the total resistance, which is 50, gives me 0.2 amps, and then just do V equals IR again. V equals IR, but I want to find the voltage in the 30 ohm resistor, so 0.2 times 30 also gives me 6 volts. Okay? Right. That is it. That is potential dividers. 3 examples that are in the notes that you need to know, but it's just simply using those 2 equations. Every time you see 2 resistors beside each other, think potential divider. You can use this equation, or you can use the other equation, V1 over V2 equals R1 over R2, or you can even use Ohm's law twice. Okay? They're not tricky, just practice makes perfect. Okay? Now, just want to show you this here. Okay, this is a Newton balance. But just before I go, I want to share with you something about the balance of life. Okay, so you're doing all this stuff. You've got all these prelims coming up, National 5. You've got all of this busy stuff coming up, but you've got to get the balance right. If you just go full on with every subject, you're going to burn out. You need to find the balance between work and play. National 5, this is coming from Mr. Bull. Find the balance, just like a Newton balance. Alright, National 5, I hope to see you next week where we start to close up electricity as a whole. Alright, right, see you later, National 5.